we're moving past congruent figures this unit, and we're focusing on figures, polygons, different shapes that are similar, not exactly the same. Now, the first thing we need to know is, what does it mean if two shapes are similar? It means that the two figures have the same shape but not necessarily the same size. So maybe they're both triangles, but there's going to be one that's bigger than the other. They're similar, they're the same shape, but they're not the same size. Little triangle, big triangle. Little quadrilateral, big quadrilateral. Okay, so the shapes are no longer congruent, but they are similar. So if two shapes are similar, then there's two things that we know about them. One thing has to do with the angles, and the other has to do with the sides. If two shapes are similar, then their corresponding angles, or angles that go together, are congruent. Okay, so angles that correspond are exactly the same. It's the sides that things now are different than they were last unit. So corresponding sides, they're not exactly the same because one triangle, one pentagon, whatever, is going to be bigger than the other. So they're not congruent, they're proportional. Which we were talking about proportions last section, so that kind of stuff plays in here too. Those two pieces of information, angles being the same, sides being proportional, those are the two things that you need to know to solve all of these problems. Okay, now there is a symbol, and I guess we should add that in there too. So back up at the top here, just like there was a symbol for congruent, there's a symbol for similar. So make sure you note this because you're going to see it. The symbol, it's just that little squiggly thing. So it's not the equal sign underneath it. It doesn't mean congruent. It's just the squiggly thing. That means similar. So we're going to see that right here in example 1. This is called a similarity statement. Okay, really the same idea as a congruent statement was. It's just telling you which two shapes are similar, and it shows you by the order of the letters which angles and which sides correspond. So they're telling me that this triangle, DGF, is similar to triangle HMK. If they're similar, I know these two things, these properties apply. Okay, so I just want to say, how big is angle K? Well, corresponding angles should be congruent. So I know K goes with angle F. So K and F correspond. I'm going to fill in using the fact that I know that there's 180 degrees in a triangle. Angle F would be 50, so that means K should be the exact same thing. Okay, same thing. Those two would both be 60, those two would both be 70. So angles that correspond are the same. It's the sides, you guys, that's going to be just a little bit different than we saw last unit. So I want to find side HM right here. That corresponds with side DG, and the sides should be proportional. So here's what I need to do. I need to figure out how the sides are related on these two triangles. So I need to write a ratio relating the sides. The two sides that I have that correspond, that I'm given both measures, are DF and HK. DF is 6, HK is 9. So down here, I'm going to write how the sides are related. So if I say, okay, 6 over 9, I write a ratio, and I reduce that to 2/3. This shows me how the sides on the triangle should be related. So for every 2 meters on this triangle, there's 3 meters on this triangle. Okay, so if you take two sides and you make a ratio out of it, This is called a similarity ratio. Okay, you use the similarity ratio to find missing sides in similar figures. And really all unit, if I'm finding a missing side, I need to set up a proportion. So here's what I'm going to do to find side HM. I'm going to take the similarity ratio, 2/3, and I'm going to use it in a proportion. And I'm going to have HM being used on the other side. So let's see, I went little triangle over big triangle, so I'm going to stay consistent, just like we saw last time. HM, we said, goes with DG. So I did little over big, so I'm going to say this should equal 5 over HM, should be in the exact same ratio as the original sides were, 2:3 or 6:9. Okay, so I did this over this equals 5 over HM. So I'm looking at something like this, which we all should be able to solve. 3 times 5 is 15 divided by 2. HM should be 7.5. I'm just cross multiplying and dividing. I'm going to do the exact same thing to find GF. So the sides should all relate in the ratio of 2:3, 2/3. So on the other side of my proportion this time, let's see, GF goes with MK. So I don't know GF, and that's in the small triangle, so I'm going to put that on top. But it corresponds with the side that's 8.4. So I kind of just did this over this equals this over this. I'm going to cross multiply and divide, and I should get 5.6. Okay, so that's kind of how you find missing sides in similar figures. You set up a proportion. That's kind of the same thing we're going to be using to answer the question in example 2. Example 2 says, are the figures similar? So I don't know that they're similar like they told me on example 1. I have to determine that. So if they are, they say write a similarity statement and give the similarity ratio. So it's kind of example 1 in reverse. Now, if two figures are similar, these two properties have to hold true. So always check the angles first, because that's way easier to tell. Let's see, I see one pair of angles being congruent right there. I see another pair being congruent up here, and I see this third pair being congruent. So I have 3 pairs of congruent angles, so the angles check out. Now I need to check and see if corresponding sides are proportional. If they're proportional, you guys, they have the same ratio. So just make a note. I checked out the angles. Now I gotta check the sides. And I'm gonna write ratios and see if they end up all being the same. So I gotta figure out what sides go together. And I'm going to use the marks to do that. So like 1 mark and 3 marks. The side between that is right here. 1 mark and 3 marks. Those 2 pieces go together. So I'm going to make a ratio out of that. 18 over 24. You always want to reduce your ratios. So if I divide both of those by 6, I get 3/4. Okay, I need to check the other 2 pairs of sides. So this side right here, AB, it's the side between the 1 mark and the 2 marks, which is actually this one right here. So 15 and 20 go together. So I'm going to make a ratio out of them. And I need to reduce it. If I divide by 5, I get 3/4. And then I'm going to make a ratio out of 12 and 16, the last pair of sides that go together. And hey, what do you know? If you divide both of those by 4, you get 3/4. Okay, if all 3 of your sides came out to be the same ratio, that means that the sides are proportional. They're in the same proportions. So the second property of similar figures held true. So they are similar. So So I'm going to say yes, the two triangles are similar. I need to write a similarity statement and then give the ratio. Similarity statement is this little kind of statement we saw here in example 1. So I'm going to say triangle, we'll call it ABC, is similar to triangle, and make sure your order matches up. 1 mark, 2 marks, 3 marks. So I need to say FED. And then the similarity ratio would be the ratio that I got every time I reduced. So I'm going to say SR for short is 3 to 4. Okay, so there's my similarity statement. Similarity ratio is 3 to 4, which you could write as a fraction 3/4. But remember, ratios, there's more than one way to write it. So we're good. Okay, on the back, 2 more examples. This is very similar to example 1. They're telling me that this quadrilateral is similar to the bigger quadrilateral. We want to find the value of each variable. If you're ever finding a missing side in this section, you need to set up proportions. And then you're going to cross multiply. Okay, so missing side, you set up a proportion. You need to find 2 sides that correspond where you have both measures. So notice that's the 5 and that's the 10. So the similarity ratio, these 2 shapes are related, and the ratio 5 to 10, which is just 1/2. Okay, so for every 1 inch or whatever the unit is, there's 2 here. Basically, you guys, the bigger quadrilateral is just double whatever the smaller one is. Okay, so I'm going to set up 3 different proportions because I have 3 different variables. Let's do x first. Let's see, x goes with 10 here. So I can use 5 over 10 or I can use 1/2. It doesn't matter in your proportion. I'm going to show you setting up a proportion using the original 5 over 10. So to find x, I would do like 5 over 10 equals, come back to the little quadrilateral and say 10 over x. So 5 over 10, 10 over x. Then you just cross multiply and divide, and you should get x is 20. To solve for y, I'm going to stick with it. I'm going to go 5 over 10 equals, come back to the little shape, y goes with 35. So y over 35. Again, I just did 5 over 10 equals y over 35. Cross multiply and divide, and this does come out a decimal. You should get 17.5. To get z, I'm going to go back and say, okay, 5 over 10 equals z over 15. And then you want to cross multiply and divide there, and you should get 7.5. So missing sides, proportions all day. Last example, so this is a really good example of similar figures in real life. If you have like a car and then a model of the car, they're going to be proportional. Otherwise, I mean, the wheels are going to be the same size in relation to the actual car. The windows are the same size in relation to the actual car. Okay, so a scale model of a figure is a great example of similar shapes in real life. And they're saying, hey, you want to make a scale model of your car. The ratio of the actual car to the model is 12 to 1. So for every 12 feet on the car is going to be 1 on the model. The car measures 13.5 in length. So let's label that. And it measures 6.2 feet in width. So we'll kind of just do that here. I want to find the dimensions of the model car. Okay, so again, if you're ever trying to find a length in similar figures, you need to set up a proportion. So let's find the length first. You're going to take your ratio and make a fraction out of it, 12 over 1. That's obviously the big car, or the car, over the model. So I'm going to do the car's dimensions over the model's dimensions. The length of the car is 13.5. We don't know the length of the model, so I put X on bottom. Cross multiply and divide. Maybe check that you're doing it right. You should get 1.125 feet. We're going to do the same kind of thing to find the width of the model. Take your ratio, 12 to 1. You did the car over the model, so you got to do the car over the model. The width of the car is 6.2. Please say why. I don't know the width of the model, so put that on bottom. Cross multiply and divide. And you should get 0.52 feet. Okay, so the dimensions of the model would be my X and my Y here. It'd be 1.25 feet by 0.52 feet.